So let's take a look now at review concept check. Alright, so the question one is, this is 4 parts of this question one. What is a convergent sequence? And then B, what is a convergent series? Notice the difference, sequence and series. Series number is a sum. This one is just a list of numbers. What does limit as n approaches infinity of an equals 3 mean? So this is the sequence right there. And then here, D, what does this summation of from n equals 1 to infinity of an equals 3 mean? Remember, this is a series. That's a sequence. And let's take a look at the solution. Alright, so here is the solution. So part A. So what is a convergent sequence? Well, again, you could just recall from my earlier video. So again, we're reviewing basically all my earlier videos on this. So there's a link to the Hive article, which includes the video inside, and the notes. And here I just put a screenshot from my calculus book just because it's a bit more compact and neat. So here's the definition. A sequence an, right here, is a sequence, just a list of numbers, has the limit L, and we write limit as n approaches infinity of an equals L, or an approaches L as n approaches infinity. And if we make the terms an as close to L as we like, if we can make the terms an as close to L as we like by taking n sufficiently large to get it, basically infinity, and then that's what you write it like here. It has a limit. So if a limit as n approaches infinity of an exists, so it actually approaches a number L, we say the sequence converges or is convergent. So that is basically what a convergent sequence is. It converges to the number L. So we can make n as large as we want, and then an will just approach L. If it does, if the limit does exist, then it converges. Otherwise, we say that the sequence diverges or is divergent if it goes to infinity, or even alternates between positive and negative. You have a number that's not approaching 0. So if it goes to -1 + 1, -1 + 1, again, that's divergent, but it's not going to infinity. Anyways, here's the following graphs show sequences that converge to the limit L. So if you have here, again, sequence is just a list of numbers. So if something goes like this, and there's L, and it goes as you go to infinity, it's approaching all the way to this limit. And you could also go up and lower it as long as you're going smaller and smaller and smaller to it. So there's the limit. So that's a convergent sequence. Again, just series, a list of numbers. So now let's look at part B. Part B is what is the convergent series? Remember, a series is summation of them. These are just the list of the numbers. Now if you're actually summing them up. So recall from my earlier video, here this one is on infinite series right here. This video was on infinite sequences. This one's on infinite series. So here's definition. So given a series, and the summation n equals 1 to infinity of an equals a1 plus a2 plus a3, etc. So remember, you're adding as opposed to just the terms a1, a2, a3. Let Sn denote its nth partial sum. Yeah, so that's what you have. If you have Sn, this just equals to the summation from I equals 1 to n, so a of ai, equals a1 plus a2 all the way to an. If the sequence Sn, so now the sequence of the partial sums, is convergent, and limit as n approaches infinity of Sn equals S exists as a real number. So basically instead of doing the limit of the sequence of just the numbers, now we're going to look at the sequence, the limit of the sequence of the partial sums of these numbers. And then basically the limit n as approaches infinity of Sn equals S exists as a real number. In other words, the limit exists. Then the series, the summation of an is called convergent, and we write a1 plus a2 plus etc. all the way plus an, and plus all the way to a infinity equals S. So it has a limit. Or the summation from n equals 1 to infinity of an equals S. So basically, if this limit is approaching this, if the summation is approaching the limit, this one is just the limit of this number of this sequence. This one is the limit of the summation of the sequence. So that's a series. So the number S is called the sum of the series. Otherwise, the series is called divergent if it doesn't approach a number. So yeah, so that is a convergent series. And now let's look at part C. What does limit as n approaches infinity of an equals 3 means? Let's go over here, part C. So what this means is the terms of the sequence, an approach 3 as n becomes large. Yeah, so as n approaches large here, this is an is approaching 3. That's the limit. So again, it's just something like that. So this is 3, then as it's getting large, it's approaching it. And then now if we look at this one here, what does this summation of f from n equals 1 to infinity of an equals 3 mean? So now the summation of the terms is approaching 3. So by adding sufficiently many terms of the series, we can make the partial sums as close to 3 as we like. So now, again, the series, we're a convergent series, we're dealing with partial sums approaching a limit. And then the sequence, we're just dealing with the number itself approaching 3, or the list of numbers that sequence is approaching 3.